In order to be a polynomial, there are certain rules that you can't break. For example, we cannot have any variables as exponents. If we do, then that is not going to be a polynomial. Other rules that would make things not a polynomial would be fractions in exponents or negative numbers in exponents. So these other three actually do not break any of the rules. These other three functions are examples of polynomials. We can have coefficients that are irrational, that's okay. We can have coefficients that are fractions, that's fine. And we can have things that are not multiplied out. All of these are still polynomials. But this one's not because of that variable in the exponent. So for the ones that are polynomials, let's talk about what their degree is. The degree is going to be the highest exponent in the problem. So for this first polynomial, my degree is 4. My highest exponent is 4. If we skip down to this last one, my highest exponent is 8. And be careful because this one was not written in descending order. My highest exponent was not in front. So just look in all your terms for your highest exponent. But this time my degree is 8. And then for that one I skipped over, I'd have to think, what would my highest exponent be if I did multiply this out? Well, without doing the full problem, I know that at some point I would get an x squared. And then I would still need to be multiplying that by 3x. Oops, I wrote my wrong term down there. I'd have x squared. I then at some point have to multiply that by 3x. And so without working out the entire problem, I know that my highest exponent is just going to be to the third power. So this one would be degree 3. You can also kind of look at this and sort of count up your x's, I suppose, if you want to think of it that way. We have 1x here, and then we'll have 2 of them in the parentheses, so 1, 2, 3 would be a way to think of that as degree 3. And then the final part of this was to state the maximum number of turning points the polynomial has. Turning points are the maxes and mins, so the number of times your graph changes direction. So for example, a graph that looked like this would have 1, 2 turning points. Well, it turns out that the maximum number of turning points, which I'll label as just max TP, the maximum number of turning points is always 1 less than the degree. So if your degree is 4, the maximum number of turning points the graph has is 3. Now that doesn't mean it's guaranteed to have 3, but it will have at most 3 of them. We'd have to graph it and look more into it to see how many it actually does have. But the maximum is always going to be just 1 less than your degree. So for my degree 3 polynomial down here, it'll have a maximum number of turning points at 2. And then finally, my degree 8 polynomial would have 7 as its maximum number of turning points.